So this is something else I wanted to point out as well. Oh, there we go. Okay, so from here, I've seen, since you do have to take the square root of a sum, right, when you're doing the distance formula, I wanted to point this out because I've seen people make this mistake. They would say the square root of a sum is the sum of the square roots. What I'm trying to illustrate here is that's not true. The square root of a sum is not the sum of the square roots for any two positive numbers, a and b. For any two positive numbers, a and b, the square root of a sum is not the sum of the square roots. I mean, it's real easy to come up with what they call a counterexample. That is an example demonstrating two things are not equal. I mean, if you just take a and b to be 1, for instance, that's such an example, right? Because on the left, if a and b are both 1, on the left here, you have the square root of 2, square root of 1 plus 1. On the right here, you have both a and b are 1, so the square root of a and the square root of b both equal the square root of 1, but the square root of 1 is 1 itself. So we have this, you know, on the left side here, we have the square root of 2. On the right side, you have 2, but 2 is not equal to its square root. So basically what I'm trying to say is the square root of a sum is not the sum of the square roots. So that's all I'm trying to say here. Okay. All right. Okay, so as I said earlier, there's also this notion of a midpoint. Basically, suppose we have 2 points, P and Q, 2 different points, that is, in the Cartesian plane. Now, you can always draw a line segment between any 2 different points in the plane. You can always draw a line segment between any 2 different points. This is actually what I use to denote that line segment with endpoints P and Q. The midpoint, by definition, of that line segment, it's the point on that line segment such that this is true. It's the point M on that line segment such that the distance from P to M is the distance from M to Q. So it's equidistant, in other words, from P and Q. It also has to be on that line segment. Visually, let's say this was P and Q. You know, we have this line segment, right? Okay. Well, then M is on the line segment, and the distance from P, let me see if I can draw this, to M equals the distance from M to Q. So these 2 distances are the same. You might be thinking, well, how do we find such a point? Well, here's the formula, right? You can get it using the coordinates of P and Q. Okay. Basically, you're taking the average of the x coordinates. That gives you the x coordinate of M. The average of the y coordinates to get the y coordinate for M. That's what it boils. That's really what you're doing. Good. All right. So this is what we have. Okay. Let's do an example of this. So let's suppose M, right? No, excuse me. Let's suppose P and Q look like this. We want to find the midpoint of the line segment PQ, where P is this point and Q is this point. I mean, you could say, well, x sub 1 is this, x sub 2 is this. You know, x sub 1 is 1, x sub 2 is 3. y1 is 4, y2 is 2. You could say that like we did with the distance formula, but look what's really happening here. This is saying you add the x coordinates and divide by 2. Add the y coordinates and divide by 2. That's really what's going on here. That's what's happening here. Right? What are the x coordinates? We have 1 and 3, and then we divide that sum by 2. For the y coordinates, same idea, right? We have 4 plus 2 divided by 2. So we have 4 over 2, 6 over 2, which is 2, 3. Right? That's what we have here. That's what we have here. Okay, well, just as a sort of check, let's check that the distance from P to M, this is our M we've calculated, equals the distance from M to Q. Well, again, this is our distance formula, right? You know, again, if you went back, let me actually do, I did this for the other class. If you went back to the distance formula, yeah, I said, okay, let x1 is this, x2 is this, and so on. But really, what is this formula saying? Subtract the x coordinates from each other, square, subtract the y coordinates from each other, and square. You know, add the squares and take the square root, right? I mean, you could say, well, x sub 1 is this, x sub 2 is this, and so on. But really, you don't have to if you think about what the formula is saying. And same thing with the midpoint, right? Same thing with the midpoint. So from here, we have, oh, sorry, 1 minus 2 squared, right? This is the distance from P to M. 1 minus 2 squared plus 4 minus 3 squared. Okay, 1 minus 2 squared in the formula plus 4 minus 3 squared. And you take the square root of that sum, which is negative 1 squared plus 1 squared, which is this. For MQ, the distance from M to Q, same idea. 3 minus 2 squared plus 2 minus 3 squared. And then you take the square root of that. Okay? That's what it boils down to. And then, of course, you actually get the same thing. You get the square root of 2. So that's what we have here. Okay? So this checks at least that the distance from P to M and the distance from M to Q, they're both equal. I mean, technically, there is something else you have to check. We can just see that by graphing. M has to be on the same line segment as P and Q. I mean, it turns out it is, as illustrated here, right? This part is the line segment, okay? You know, from P to Q, this part here, okay? M is on that line segment, so we're good. All right, beautiful. Good. So that's what we get here. There is actually a way to check that 3 points are on the same line. Algebraically, you could check that. I'm not sure off the top of my head how you do that, but I know the book goes into it. But for us, we could just graph. Again, we have Desmo, so we can always graph. Any questions on that? All right. All right, let's do another one then. So here's another example. In this case, we have P is this point, -1, -3. We have Q is 4, -2. So we have these 2 points, you know, they're given, and we want to find the midpoint M. Okay. Well, again, we have this formula, right? What do? We add the x coordinates, right, of P and Q and divide by 2. We add the y coordinates of P and Q and divide by 2. Okay, so for this one, we have -1 plus 4 over 2. For the y coordinate, we have -3 plus -2 over 2. So here we have 3 over 2, -5 over 2, which is this. So we get that. Okay, now, let's see. Okay, let's check the distance again. Okay, so the distance from P to M, right? We have P and M. We subtract the X coordinates from P with M, right? -1 minus 1.5 squared. And we subtract the Y coordinates of P and M. -3 minus -2.5. I mean, minus a negative, that becomes addition. So we have this, -1 minus 1.5 squared, -3 plus 2.5 squared. Again, we're subtracting a negative. That's why we get addition. Now, what is this whole sum? We get this. We have the square root of -2.5 squared plus -0.5 squared, which turns out to be the square root of 7. You know, if you, again, you could do this in a calculator if you want. And then the distance from Q to M, that should be a Q. Let me fix that quickly. From Q to M, okay? Oh, capital Q. What do we get? Same idea, right? We have 4 minus 1.5, okay? Here it is, right? You subtract the X coordinates of Q and M. Subtract the Y coordinates of Q and M, right? That's what I'm doing. So we have 4 minus 1.5 squared, which is, what is that? Okay, it's 2.5. Right, over here, just like above, minus a negative, that's addition. Okay, minus a negative becomes addition. So we have 2.5 squared. Here we have 0.5 squared. And we get the same thing. We get the square root of 7. So that's good. Good. Not only that, if we were to plot these 3 points, right? I did this in Desmos. Here's P, right? -1, down 3. Q is 4, down 2 units. M, we just calculated here. And you can see M is on the line segment with endpoints P and Q. In other words, if you draw any line connecting P and Q together, M will be on that line. Okay. All right. Any questions at all? All right. 148. Okay. All right. Let me actually see if I can start the next section. 2.1. Here we go. So that was 2.1. You know, again, it wasn't that, bad. It wasn't that long. Most of that stuff, people have generally seen already. But if you haven't, that's okay though. Let me now share the next set. Here we go. So this is going to be 2.2. Okay, I'll just briefly start that. This is actually the next section. Didn't think I would get this far. In the other class I didn't, but that's okay. In 2.2, okay, what we're going to look at are actually graphs. And we're actually going to see graphs dealing with equations of 2 variables. In other words, you'll see equations like x and y, right? And you'll see what their graph actually is, what the definition of it is and how to graph it. Although some things you might know how to graph already. Excuse me, but that's okay. In particular, we'll see the parabola, okay? We'll see what that is. That actually comes about from graphing a polynomial, well, a quadratic, that is. And we'll see actually what the circle is, okay? We'll see what that is. Okay, and again, it's really just from equations in 2 variables, right? So we have seen equations in 1 variable, but now we're going to kick it up a notch and look at equations in 2 variables. And really, what is it? Okay, we'll stop here now because I'm out of time.